really lucky because I promise you they really are easy. I'm not just saying that. I think they do it on purpose, put the easy ones at the end since it's the end. But some of you really need a really good grade so that you can drop one of your other grades. So um, just because it's easy doesn't mean you cannot pay attention. You still need to pay attention. But okay, so this is law of sines. So in the course of trigonometry, when we first learned sine, cosine, and tangent, SOHCAHTOA, it had to be from a right triangle. So we learned a lot of other things about sine, cosine, and tangent. We learned how to graph it, and when we learned how to graph it, we learned that they were a curve, that it made a curve, and we learned about the unit circle and all of that stuff. But all of it came from right triangles. We didn't actually build the unit circle, but it's all built based off of right triangles. But there is a way to still use trigonometry when you have a non-right triangle. So, for example, if I had an oblique triangle like that, it's a non-right triangle, which means when on first appearance, I can't use trigonometry. But if I draw in an altitude like that, I have now created for myself two right triangles. So let's say that the big triangle, let me put letters on it. Let me say that this was triangle ABC. And whenever I draw in an altitude, that's a height. So we'll call it H. And you remember from the very beginning of trigonometry or back in geometry, the side is across from the angle. So little a is across from big A and little b and little c. Okay, well, I have now built these two right triangles inside this oblique triangle. So I really still could set up sine, cosine, and tangent. Like if I set up sine of angle C, that would be opposite over hypotenuse. So that would be H over B, right? So none of that is different than what we've done before. So I could also set up sine of B equals H over C. Now I could then solve both of those for H, right? So if I did that, let's see, this would be, I'd multiply both sides by B. So I would get B sine C equals H. And if I did the same thing over here, I would get C sine B equals H. And if two things both equal H, then that means they equal each other, right? So that means I have B sine C equals C sine B. Well, then I could just do some simple like rearranging and in this case division. If I divide both sides by C, that would give me, and then divide, so that gives me B sine C over C equals sine of B. And then if I divide both sides by B, I get sine C over C equals sine B over B. And that is the basis for the law of sines. Now, you do not have to know all of that. I'm not going to make you build that triangle. I just need you to understand that that's where it comes from. So it is still right triangle trigonometry, but we no longer have to have a right triangle. So the law of sines looks like this. It can be written two ways, and we're gonna flip it back and forth depending on what way benefits us the most. So it can be written with the sine on top. Sine C over C equals sine B over B, which also equals sine A over A. Now, you're not going to ever use 3 at one time. These are just ratios that have been set in proportion to each other. So I'm going to use whichever ones benefit me. So if I have side C and angle C and side B, then I'm going to use those. If I have A and B, I'm going to use those. If I have A and C, I'm going to use those two. So it's whatever two things that you have that benefit you and that you need. Now, If what I'm looking for, and we'll talk about this more in just a minute, if what I'm looking for is a side measurement, then I'm just going to flip this whole thing over. It could be written as C over sine C equals B over sine B equals A over sine A. It can be written in any order. It doesn't matter. You can flip them upside down, right side up. Doesn't matter. As long as if it's sine on top, it's sine on top all the way across. If it's sine on bottom, it's sine on bottom all the way across. You don't ever mix them. It can't be one sine on top and one sine on bottom, if that makes sense. It's always got to be. But whatever, upside down, right side up, we're just going to keep it in whichever way helps us the most. And I will show you what I mean by that. So now we're going to use it. Now, let me say this. Law of sines always works. It even works for right triangles. However, when we use it for right triangles, for my labs, your decimals are always going to be off just barely, just enough that they'll be wrong on my labs. So on my labs, we don't use law of sines. If it's a right triangle, we use regular SOHCAHTOA. But if it's a non-right triangle, we can use law of sines. Now, there are a couple of things that have to be true in order to use law of sines. So let's look at an example. All right, we're going to solve triangle ABC. Okay, so remember when they use the terminology solve. If they say solve triangle ABC, that means find all of the missing pieces. So let's look at what we have first of all. So A is 32 degrees. B is 81.8 degrees. Obviously, my triangle is not drawn to scale. And side A is 42.9. So first thing I'm going to do, the easiest thing to do is to find angle C because I can do that just by subtracting. So subtracting from 180, I know that angle C is 66.2. Okay, so obviously it's a non-right triangle. I have no 90-degree angle in this. In order to use law of sines, all you have to have is one completed ratio, meaning I need the angle and the side across from it. And in this case, I have angle A and side A. So I have a completed ratio. If you have a completed ratio, you can find everything else you need. So in this case, I'm missing side C and side B. Doesn't matter which one you decide to find first. Since I am looking for a side, we put sides on top. Whatever it is you're looking for, that's what you put on top. So I start with my completed ratio. So I'm going to write out what I'm looking for. I have side A and sine A, and I'm going to just go in alphabetical order. I'm going to look for side B. So this is the version of law of sines I'm going to use. So 42.9 over sine 32 equals B, because that's what I'm looking for, over sine 81.8. Now, all you're doing is algebra to solve for B. So we're going to do all the algebra first and then put it in our calculator at the end. So in this case, I need to clear the sine 81.8. So I'm going to multiply both sides by sine of 81.8. So on the right side, that would cancel that out and leave me just B, which is what I'm looking for. And then I just put this in my calculator, and I can put it in just like that. So let me type it in, and then I'll show you what I'm putting in. I'm obviously in degree mode, so you probably need to check just to make sure you're in degree mode. So I just typed it in literally like it was on my page. So if I back up over here, I have sine of 81.8 times the fraction 42.9 over sine of, see if you can see it, sine of 32. And I get 81 or 80.13. So that's side B. And that would be centimeters. And now I can find side C the exact same way. So this time I'm setting up, and always also go back to the given ratio, even though I now know side B, because I rounded this. And because I rounded this, that's not exact anymore. So I'm better off to use the original ratio that they gave me, which was this A ratio. So I'm going to do 42.9 over sine 32 again, because that's A over sine A. And I'm setting it up for C. So it's going to be C over sine 66.2. So the process is exactly the same. I'm going to multiply both sides by sine 66.2. And I'm just going to put it in the calculator. And I got 74.1. And that's centimeters. And so now I just check to make sure I've got all my pieces. I have all three angles because I wrote it inside the triangle. They gave me side A to start with, and I found side B and side C. Easy enough? I mean, it really is easy. And you don't even have to memorize that formula because it'll be given to you. So super, super easy. Okay, hold on. I'm going to stop this video.